Okay, so in the last lesson, we learned how to solve these by graphing, and what we meant by solving it is we're finding the coordinates where these two lines intersect. We're still finding where they intersect, so we're finding coordinates as a solution. So we're going to find like an x and y coordinate, but we're going to do it using math and not graphing. There's two different ways to do this using math. One is called substitution and the other is elimination. Depending on the problem, one is usually easier than the other, and you just have to be able to use either or depending on the problem to make it easier on yourself. So for the first one, we have y equals 2x minus 1 and then 3x minus y equals negative 1. Notice how y equals 2x minus 1. So what we're going to do is take this and plug it in for y in the second equation. So that is what we're going to do. So if you're working on paper, I'll zoom in for you. So we're taking 2x minus 1, plugging it for y here. So 3x minus 2x minus 1 equals negative 1. And I'm being very brave writing in pen. Okay, so now that we plugged 2x minus 1 in for y, we have one variable and we can solve this for x. So we're just going to solve, distribute the negative sign. And I get x equals negative 2. So that's my x coordinate right here, negative 2. Now we have to find the y coordinate. What we're going to do is take this negative 2 and plug it into one of these equations. It doesn't matter which one, you'll get the same answer for y. Usually you would choose the easier of the two equations, so this top one looks a little bit easier to solve for y. So y equals 2 times negative 2 minus 1. So y equals negative 5. So that is our y coordinate. And then this would be the solution. This is where the two lines would intersect. So yes, you could graph these two lines like we did at the end of last week, or you could do it this way. Okay. The next one, we're going to practice the same thing again. This one is just one step more. This one is different than the first one because we don't have like a y equals or an x equals that we can plug it right into the other one. So what we're going to do is rearrange this first equation so that it's just x equals, and then we can plug that into the second equation. So from here, to get x by itself, I'm going to subtract 3y from both sides. So I get x equals negative 3y plus 5. And then I can take this and plug it in for x in the second equation. Why is it so blurry? There we go. Everybody follow what I did? So just to recap, I rearranged this so I had an x, just x on one side and x equals, and then I took what x equaled and plugged it in for x in the second equation. Now that I have just one variable, I can solve for that variable. And if you're working ahead and you got a fraction, yeah, we get a fraction. So I get y equals 5 halves. Don't love fractions, but they happen. 5 halves, by the way, 5 divided by 2 would be 2.5. So if you wanted to write it as a decimal, that's fine with me. Yeah, if you want to. Yep. And then once we have y, then we need to solve for x. Now, I prefer to work with decimals than I do fractions, so I'm going to use the decimal when I plug it in. And just choose one of the equations. It doesn't matter which one. So x plus 3 times 2.5 equals 5. And we get negative 2.5 or negative 5 halves or negative 2 1/2, however you want to write that. Okay, there's a lot of people looking at me, waiting for me to move on. You ready? Yes, no? Okay. Okay, so that was how you solve it based on substitution. You just get one equation equal to one variable and plug it into the other. The other way to solve these is by elimination. You okay? Okay. Oh, yikes. And with the weather change, well, the weather's still warm though, so. The humidity is supposed to be good on your joints. I don't know. Or is it the opposite? I don't remember. I don't know. I'll just stick to teaching math. Okay. First example, so based on elimination, what we're going to do is we're going to add these two together like this and get one of the variables to cancel so we can solve for the other one. In this one, our 8y and negative 8y, when we add these, it'll cancel, and then we can just solve for x. So negative 2x plus 5x would be 3x. 8 plus negative 8y, that's just going to cancel and be 0. And then negative 8 plus 20 would be 12. And then we can solve for x this way. You might be saying, oh, that's a little bit easier. Depending on the problem, yes, it can be easier this way.
Do you always add?
Yes. Okay, so we get x equals 4. And then from here, we take that 4 and we plug it into one of these equations. It doesn't matter which one. Choose the easier of the two to work with. In this case, they're about the same in terms of how easy they are. But I'm just going to take this equation, plug in 4 for x, and then solve for y. Yeah. 8y equals 0. And then divide both sides by 8 and just y equals 0. So we get x equals 4, y equals 0. So our coordinate here would be just 4, 0. Okay, and for the next one, now it's going to take it one step further. In this case, when we added them, it automatically canceled, but a lot of times it won't automatically cancel. 3x plus 3x is going to be 6x. It's not going to be 0. So sometimes we have to multiply these by something to make it cancel. In this case, we're going to have to multiply one of these by negative 1, so that way the x's cancel. Another thing to note about this one is everything's not lined up. So our y's aren't lined up and our constant's not lined up. So I have to rearrange one of these so that it does line up. I'm going to rearrange this second one so that way and just put it in standard form. So I'm going to subtract 3 from both sides and then subtract y from both sides, and I'm going to rewrite it as 3x minus y equals 3, negative 3.
So why can't we add 2 3x's together?
Because you want it to cancel.
Oh, you just pick up.
Yeah. So I rewrote this bottom one now in standard form. And then what I'm going to do is when I rewrite this, I'm just going to multiply everything by 1, just kind of saving myself steps. So I'm multiplying all this by negative 1. Okay, so now I can add these two equations. The x's will cancel, and I'm left with negative 3y equals negative 9. divide both sides by -3, and I get y equals 3. So for my coordinates, my y equals 3. Then the next step is to take y equals 3 and plug it into one of these. It doesn't matter. And also, it doesn't matter if it's the one that I like rearranged or the original. It'll still come out the same because even the one I rearranged is still equal to the original. It's just rearranged. So whether I use the original or this new one, it doesn't matter. But I'm going to take y equals 3, plug it in for y, and then solve for x. Okay, so I get x equals 0, and that's my x coordinate.
Sometimes you have to multiply both, like multiply.
Yes, we're going to get to that in the next example, actually. Or were you looking at the next example? Yeah. Okay, you got it? We're moving on. Okay, number 5. Shreya asked if sometimes you have to multiply them both to get them to cancel, and yes. So in this example, we want either the x's or the y's to cancel. It doesn't matter which one you decide to cancel. Like, if you multiplied this by 2 and this by 7, you could get the y's to cancel. The way that Miss Adams did it in her answer key is she canceled out the x's. She multiplied this by 5 and this by -3 to get the x's to cancel. But either way you would do it, it's fine. So I'm going to multiply everything here by 5 to get 15x plus 35y. And then multiply all this by -3.
35y.
Yes.
Can you also multiply by 2 and 7?
You could, yes. Well, 2 and -7, like one would have to be negative. Is that the way you did it? Cool. So then you can check and see how it comes out. So at this point, I can add these together. The x's will cancel. Then I get 29y equals 87. Divide by 29. Y equals 3. So as far as my coordinates, I get the y coordinate of 3. If you did 2 and 7, then you would have gotten the x coordinate. And then once you get one of the coordinates, just plug it back into one of the equations and then solve for the other variable. That's what 3 equals 15. And I get x equals -2. Okay. Next, number 6, same idea. We're going to get either the x's or the y's to cancel. We could multiply by 8 and 7 or 9 and 5. Let's do 9 and 5. So I'm going to multiply the top one by 9 and then the bottom by 5. I'm not going to do a positive negative this time because this y is already negative. So just by multiplying by 9 and 5, it should work. So 9 times 7x would be 63x plus 45y, 18. Then times 5 would get 40x minus 45y. And 5 times 17 is 103. Wait, no, it's not. I lied. What is it? 85. 85. Sorry. This is 85. Okay, so 40 plus 63, 103x. This cancels. and then equal to 103, so x just equals 1. So all of that to get x equals 1, yes. Then once you have x equals 1, just plug it into one of the equations. It doesn't matter which one. And y equals -1. Okay, now we have 2 word problems on the next page. Okay, the word problems, we also saw these on the PSAT as well. Same idea, the only thing is we have to set them up. These are pretty predictable though. It's almost like the same situations over and over, obviously with slightly different scenarios, but the equations almost always look the same. So here we go. At a park, there are 38 people playing tennis. Let's closer. Some are playing doubles and some are playing singles. There are 13 matches in progress. Okay. A doubles match requires 4 players. Singles match requires 2 players. Write a system of equations and determine how many matches of each kind are in progress. Okay, so we're going to use a D for the number of double matches. Double matches. We're going to use S for the number of single matches. And then from here on out, so total of 13, so D plus S equals 13 matches total. And then there are 38 people playing. So for doubles matches, you would have 4 people times the number of doubles, plus for single matches, 2 people times the number of single matches equals 38 total. And then here's our 2 equations. Okay, so for this we could use elimination or substitution. It's up to you. What do you want to do? Elimination. Okay, so what we're going to do is we're going to multiply this by -2 or -4. I'm just choosing -2 because the s's will cancel. So then I will say, okay, this will be -2d plus -2s equals -26. I can actually just add it to that. And then I'll get 2d equals 38 minus 26.
How did you get -2?
So I multiplied everything by -2, so the s's will cancel. Were you thinking -4? -4 would work too. The s's cancel, and then 38 minus 26 is 12, and then d equals 6. So the number of double matches is 6. And then for S, you could just plug this in and solve for S. So S equals 7. So the number of single matches is 7, and there we go.
Hold on.
Okay.
So we're not writing coordinates, right? Because
Mm,
this would make sense.
yeah.
Is that +5 or +s?
Plus S. Then number 8, a group of students take their math teacher out for lunch. Oh, that's nice. If 5 have hamburgers and 4 have hot dogs, so 5 have hamburgers, 4 have hot dogs, we'll call it hot dogs D. The bill will be $19.50. If 4 have hamburgers and 5 have hot dogs, the bill will be $18.75. What is the price of a hamburger? What is the price of a hot dog? Okay. I'm going to use elimination again. So we'll multiply both of these by, let's do 4 and 5. Let's do 4 and -5. So that way the hamburgers cancel. And then I'm going to rewrite it. 20h plus 16.
9 people, less than 20 bucks.
I don't know. That is pretty cheap. 4 times 1950 is $78. And then all this times -5. Okay, so here, hamburgers cancel. 16 plus -25 is -9. D equals, when you subtract these, you get -1575.
Didn't you add them?
Well, yeah. I was just,
Oh, but it
yeah.
is
78 minus 90, I don't know. However you think of it. And then divide both sides by -9. Hot dog is $1.75. Costco.
Costco's $1.50.
Oh, it's even cheaper than that?
No, it's $1.50.
Okay, so once we have the price of a hot dog, we can just plug it into one of the equations and solve for hamburger.
Use hot dog to solve for hamburger.
I don't get it.
I don't know why that sounds so weird.
I don't know. Let's see. 4 times 175 is 7.
It's kind of really cheap.
And 1250 equals 5 each. Yep. $2.50 for the hamburger.
That's definitely fast food for sure.
And McDonald's maybe. Not even then, like not the crazy. Okay. That's all for the lesson.